An enormous comet hurtles toward Earth, threatening to wipe out New York City. It's a scenario most people think exists safely in the realm of movies like Deep Impact. But the threat of comets and asteroids is frighteningly real.
We are in the middle of a shooting gallery, and eventually a collision will take place. It's just a matter of when.
We know the Earth has been hit by asteroids throughout its history, and the easiest way to see that is just to look up at the moon, with all those thousands of craters. Every one of those craters is the scar of an asteroid impact.
The impact of even a small asteroid hitting Earth is hundreds of times more powerful than an atomic bomb. A large asteroid, 10 miles in diameter, could wipe us out entirely, traveling at extreme speed. Up to 20 miles per second, it would release a colossal force of energy upon impact, carving out a huge crater in the Earth and vaporizing everything around it. Hot debris would blast out through the atmosphere and rain back down, creating a firestorm that would engulf the whole planet. We've covered a lot of dire threats in this program tonight, but only one of them is widely acknowledged to have already caused at least one mass extinction before: the impact of a near-Earth object, an asteroid or a comet. And most scientists now believe that's what killed off the dinosaurs 65 million years ago. It slammed into what is now ocean off the coast of the Yucatan in Mexico. We know because of the scar that remains even now, a 100-mile crater on the ocean floor. Other telltale clues were left behind, like iridium, a substance naturally formed in space, but very rarely on the surface of Earth. It confirmed scientists' theories.
You can find this in deposits in Montana and Arizona, in Indonesia. Everywhere you look, when you look at the boundary layers between the geological layers of rock where the dinosaurs died off, there's this iridium layer.
Asteroids of all sizes have collided with Earth in the past, and without any doubt, they will crash into us again.
We have to realize that every 100 years or so, an object that could destroy a modern city hits the Earth. The last one was in Siberia. The famous Tunguska explosion took place there. If that thing had hit New York City or London, it would have completely flattened everything out to perhaps 10, 20 miles.
Meteor Crater in Arizona is one of the most obvious scars that remains tens of thousands of years after a near-Earth object hit, obliterating everything in its wake. An asteroid like the one that hit there could hit a populated area at any time.
If it lands in an urban area, we're talking about hundreds of thousands and millions of people losing their lives immediately. Or if one of these objects would, for example, land in the sea, it would, even though it was small, generate large tidal waves that could kill hundreds of thousands of people who live on the ocean.
You might think that given the high probability we'll be hit by an asteroid, there'd be worldwide interest in tracking them. Think again.
That's the oxygen line. And
I used to say that the number of people working on protecting the Earth from asteroids was about equivalent to one shift at a McDonald's.
David Morrison of NASA is a pioneer in the field of near-Earth object impact research. He oversaw a monumental NASA report in the early 1990s, urging Congress to fund a near-Earth object hazard program.
Now I guess we'd say that there were 2 or 3 shifts involved. But it's still a very small effort considering the magnitude of the threat that we're trying to protect against.
It wasn't until 1998 that the U.S. launched a formal program to track asteroids. Called SpaceGuard, it collects data from a handful of survey telescopes, like this one at Kitt Peak in Arizona. Here, a huge automated telescope probes the solar system, searching for the largest, most threatening asteroids. Data on potential asteroids spotted here is shared online with astronomers around the globe. Collectively, the scientists, aided by an active group of amateur astronomers, confirm and track the asteroids. Since SpaceGuard began, it's been finding about one per night.
The main goal was to find those larger than 1 kilometer. About 2/3 of those that we estimate are out there of that size have now been found.
It turns out that most of the big asteroids are located between Mars and Jupiter in the asteroid belt and stay in their orbit, where they don't pose a threat. About 900 of them have been identified. But there's a lot we still don't know about the hundreds of large asteroids we haven't found yet.
The ones we have not found, we don't know where they are, and they could hit without notice.
And some of the ones we have found are cause for high anxiety, especially one called Apophis.
This thing is the size of the Rose Bowl. It'll be the biggest, closest thing we have ever seen come near Earth. In April, in the year 2029, on Friday the 13th, this thing will come close enough to Earth to dip below our communication satellites.
At that point, the asteroid's orbit will change, and it could go through what's called the keyhole.
That keyhole is just the right distance from Earth so that Earth's gravity will make sure that it hits us on the next encounter, now in 2036.
If Apophis does start orbiting toward us, the odds it will hit the Earth are 1 in 5,000, making it more likely to kill you than a plane crash. And asteroids are not the only lethal celestial object on the loose. There's another potent menace: comets.
Comets are like a wild card. They're like a rogue assassin. You can't really predict them. You don't know when they're coming in.
Unlike asteroids, comets don't stay in a fixed orbit. They can fly in from galaxies out of sight. By the time we spot them, it could be too late.
In a worst-case scenario, a comet that could wipe out all life on Earth could conceivably jump out from the backside of the sun and hit you in just a few weeks, and we wouldn't know what hit us.
In 1994, scientists were able to observe a comet smashing into Jupiter to witness the incredible damage they can inflict.
The comet shattered into 24 pieces and rammed Jupiter repeatedly. These explosions left scars on Jupiter the size of the Earth.
So far, millions of dollars have been spent on these missions to learn more about asteroids and comets. And yet, not a penny has been invested to prepare in the event that one of them is headed toward Earth. Representative Dana Rohrabacher has introduced a bill in Congress that would expand the U.S. Near-Earth Object Program, but he's fighting an uphill battle.
Our government and different governments around the world are mainly concerned with the problems at hand on the day they go to work.
Is anybody geopolitically thinking about this problem? The answer is no. There is no international organization that will consider how to address such a threat were we to find that one was imminent.
The good news is scientists agree that in theory, diverting an asteroid wouldn't be hard. For years, they've been mulling over the possibilities.
If you watch the movies, it's obvious what you do. You just blow them out of the water. Actually, that's the last thing you want to do. If you blow up a meteor or a comet with our name on it, all of a sudden you have lots of little comets and little meteors with our name on it, causing much more damage, in fact, than just one meteor or one comet.
One idea proposed is using a mirror to beam sunlight at an asteroid to change the amount of light it absorbs. This would alter its gravitational pull and change its orbit. Another idea: attach probes to the asteroid with thrusters and sails that would alter its course. The problem is, it's a huge challenge to attach anything to an asteroid or comet, because every one of them is completely different.
Comets are ice balls. Some asteroids are stony.
Taking the lead in the ad hoc community of scientists looking for ways to fend off asteroids is pioneering astronaut Ed Lu. He's teamed up with colleagues to form the B612 Foundation, a nonprofit group dedicated to finding a solution.
We wanted to make it be something that was actively trying to do something rather than simply studying the problem. And we thought that we ought to fly a test mission by 10 years.
In 2005, Lu came up with a novel idea called a gravity tractor, a rocket that hovers near an asteroid, using gravity to slightly alter its course.
What you would actually use is just the force of gravity attracting the two together to pull it.